All right, so anyone have any specific questions about the reading?
Nope.
I did, but I didn't write it down, so I'll get by.
Okay. And for me, I don't have any specific questions, but just kind of the application of it all didn't make too much sense, so I'm hoping the quiz helps with that.
Yeah.
All right, I guess we can just go ahead and get started with the quiz then.
Let's do it.
Question 3, so using the normal probability applet to find the combined area under the standard normal curve, that is to the right of z 1.358 and to the left of negative 1.358. Round your answer to 3 decimals, for example, that. For that I got, excuse me. So that one was simple, just highlighting or just
Shading in.
shading in, thank you, the left and right side. And I got 0.175.
Yep.
That's what I got.
That's what I got.
Cool. Okay, who wants the next question?
I'll do it. Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population? 1, the distribution of the individual observations? No. The distribution of the sample means? Yes. This cannot be determined by any information given. That's not it. So it's the distribution of the sample means.
So why is it the distribution of the sample means?
Because it says the 9 observations are randomly drawn from your population. It's not the individual one because it could be less or more. It's the sample means because that's constant, and it says of X bar. So this was X. If this was X bar, that could have done if it was the individual. But this one says it's X bar because it's a broad range of it. So it's the distribution of sample means because it's specifically saying X bar itself.
Okay.
I believe you, but I don't understand it.
Yeah.
That was the one that I chose out of logic, but couldn't back it up.
Okay. So this one's bigger because if you look at the first one, the distribution of individual observation, that would be bigger because it's X, not X bar of the range. This is the X bar means like the range of it. So it's the distribution of sample means. That's the smallest one that you can have. And it can't be not determined because they already gave us what it was. So that kind of goes out of the package. But X is more and X bar was less. So, because if it was saying it was more of the standard deviation, then the first one would have been correct.
I think that's the logic I used.
Yeah, so that's what I looked at it.
All right, number 5. Which of the following results implies that the spread of X bar decreases as the sample size increases? I went with the law of large numbers because that's
what I did.
The definition.
Yep, it's right out of the book. So like.
Okay.
I'll do 6. So we have to use scores and quantitative portion of the GRE are approximately normally distributed with mean equal 150.8 and standard deviation equals 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score responding to Diane's score? Round to the nearest 3 decimal places. I got 1.045.
That's what I got.
Let's check.
X minus mu over standard deviation. Just put in plug and chug.
Yep.
Do you want to do number 7, John? Or do we already just, yeah.
Oh, I was just calculating
Oh, okay.
number 6 real quick, just because I haven't
Okay.
gone through the quiz yet. I mean, I read, but
Okay. Yeah, it's just x minus mu over standard deviation. So 160, 50.8 divided by, so all that, and then divided by 8.8. You'd get 1.04545, but you have to round it. So it'd be
Okay.
1.045.
okay. So it says, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So I'm assuming you would take the z-score of the 1.045 and highlight above the positive 1.045, and that would give you the percentage of, or the probability number of how many would score above that.
Correct.
So 0.148.
Yep.
Yeah, I got 145.
145.
I got
Yeah.
148.
I got 148.
All right.
But you probably got yours right, didn't you?
Yep. I did.
So
that
with
means 3 of us are wrong.
They do have a buffer on this too, because they use 2 different ones. They use SPSS and Excel.
Oh, that's right.
But so they do have a little bit of give on that. But I 0.145, but I used Excel, so.
Okay, and I was just using the normal probability applet to show.
Well, huh? Yep.
Yeah,
yep,
me
yep.
too.
So you guys can put that too. Just up to you guys.
I'll
Go
try
for
one.
it. We'll risk it.
All right, cool. Go against the grain. That's what I like. All right.
8?
Is it my turn?
Yep. I think it's me, isn't it?
Yeah.
Yeah.
I think.
Cool.
All right. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the Z score? Mean of the student scores. I got 2.338.
How did you figure that one out?
All right. Let's go back into my notes.
I put all of those scores in that other spreadsheet that we're supposed to download. Is that the right approach?
Yep, that's what I did.
Okay.
Means by these scores, right? In 3 decimal places. Now I need to try to find it again. Gosh dang it.
Was the other sheet we were supposed to download in the reading?
Well, it was for
Yeah.
a couple of weeks ago, I thought.
For a
from
week
a couple
ago?
weeks ago?
Or, well, that quantitative descriptive statistics is what?
Yep, descriptive statistics. Yep. The histogram and the defective stats one.
Yes, that's the one. That's what I used.
Yep. That's what I did as well. Score. Whoops. Okay, percentiles. I can't find my notes. Where
It's all good. I can go through and try and figure out how to do it after.
Well, what I have is 160 minus 150.8 divided by 10.05 square root 5. That
How'd you get that one again? On the 10.5 one?
I didn't. Isn't 10.5 the? That's the standard deviation. Oh, you know what? I rounded that up. Maybe I wasn't supposed to round that.
It's just 10, I think. The standard deviation is just 10.
You think it's just 10?
Technically 10.04. Yeah, technically it's 10.04. It doesn't say to round.
That would have affected my answer then.
Mm-hmm. Standard deviation of 10.0498.
Yeah.
That's
Crap, and I forgot what the formula for that one is.
So this isn't solving for Z.
Oh,
This was solving for Z.
yeah, it's solving for Z score, right? Yeah.
So So you said you got 1.84 for Z?
I got 2.047.
Okay, and I could have put it
I'm
wrong in
looking
the
on the
calculator. Oops, I did put it wrong in the calculator. Divided by 10 divided by 5. 2.057, or you said 2.04?
I got 2.0469 for
For a Z score?
yes. Is that close to what anybody else had?
I'm still working through it.
I did the 160 minus the 150.8, right?
Yeah.
And then that got me the 9.2. And then 9.2 divided by 10 over the square root of 5. because the number of samples we had was 5.
Yeah, that's
And that, oh, go ahead. And so that gave me 2.057 as a z-score.
I put it in my calculator as one equation. I don't know if that makes a difference.
Make sure you put your parentheses around where you need to as well, because it goes order of operations.
Yeah, I've got parentheses around the 160 minus 150.8.
Okay.
And then also around the square root of 5.
Where'd you get the
Yeah.
150.8 again?
That is
In the
the
big, it's the mean and the standard, or what is it?
So the 150.8 was what was used for the previous standard deviation.
Oh, okay.
yeah.
That's fine. Okay.
I'm gonna grab my graphing.
correct?
Negative, positive.
You got what for your answer? 2.338?
Yep. Is that what? Did you get that too?
I'm about to try.
Okay.
Since I don't trust my inputting skills on the computer.
And did you use the 10.04 or did you just use 10 for the?
My standard deviation using the quantitative descriptive statistics Excel sheet is just 10 or 10.049. So
Yeah.
But do you round that or were you just using 10?
No, you never round until the end.
yeah, so I guess you would use the whole thing, the 10.0498756.
That's
Yeah. That's what I would do.
160 minus 150.2. 10.046 square root of 5. Okay, I got 2.18.
What'd you get again?
2.18.
I got 2.338 though.
You got 2 point what?
338.
338.
Uh-huh.
I keep getting 2.047.
Oh, that's why it keeps screwing up.
Blake, have you checked your answers already?
Yeah, I already checked them.
So you know yours is right then.
So
Yeah.
I'm getting the 2.338 now. Because the
Yep.
standard deviation given in those 5 examples isn't the standard deviation you're supposed to use. You're supposed to use the mean and standard deviation given at the start of the first GRE problem, which is the mean of 150.8 and the standard deviation of 8.8.
Oh.
Yeah.
That is how you get the 2.338.
Good call.
I did not even see that.
Yeah, so it says use that for the next 4 problems, and this is only problem 3. So those are the numbers we were supposed to use.
That makes more sense now.
Okay. Well, thanks for catching that, John.
Yeah. Because the sample mean is still 160.
Right, right.
Still using the standard deviation from above.
Makes more sense now. Cool. Who's got number 9?
Must be my turn. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So I'm probably wrong because I did this with the wrong standard deviation.
Yep.
So I'm gonna have to redo that.
0.0097.
That is what I just plugged in and came out with.
Okay. That's what I got as well.
That was 0.0097.
Correct.
Yep.
Rounded to 00 or 010.
No, don't
No,
don't do that until they ask you that. So just put down 0.0097.
That's right, because we're still using this for the next question.
No, that's the last one.
Is it?
That's the last one on that one. Yeah,
Okay.
but good rule of thumb is don't round unless they ask you to.
it says round to the nearest 4 decimal places.
Oh, you're right, it does.
So the answer given is technically 4 decimals, the 0097.
Yep.
Ready for 10?
Let's do this.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected? I put approximately normal.
That's what I put.
And that's because it is greater than 30 from the previous
Correct.
on Tuesdays.
That was my logic.
That was my logic.
Okay.
Yep.
All right, question 11. What is the mean of the distribution of the sample means, or the sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? What would be considered the parent population?
I think you have to pull up that other applet thing.
Are they just asking for the standard? I think they're just asking for the standard deviation.
That's
Are
what I thought.
I got 3.5 because it says that BYU Idaho since the 3.5 standard deviation.
That's what I put.
Well, 3.5 is the mean. The standard deviation is 0.7.
Oh, yeah, the mean. My bad.
Okay.
Mean of the distribution of the sample means. That's what's asking, right?
Okay. And then the next one's asking for
3.5?
the standard deviation.
Yeah, they're not asking for standard deviation. They're asking for the mean.
Okay.
And as of the thing up there, it says 3.5, so that's what I put down and got it right.
I
Right.
spent too long thinking about it, and finally, that's what I came up with.
I do that too much in a lot of my classes.
And then question 12 is 0.7.
0.7. Oh, I put for 12. I got 0.078.
0.78. How'd you get that? Do you know?
All proposal size 81. 3 decimal places.
Because it's, oh wait, no.
Distribution of the sample names. Think,
So you said 0.078?
Yeah.
So because we're dealing with X bar, the standard deviation of that is actually the standard deviation given over the square root of the number of random samplings given.
because the 0.7 is only X, right?
Yes.
Because we have to put an X bar. So that's what you had to do over the mean, right?
Yeah, so it would be 0.7 divided by the root of 81, which is 9. But so
Yeah.
0.7 over 9 gives you 0.078.
7, 8. Is it me?
Yes.
Sure.
All right, why not, right? What is probability of the mean GPA for 81 randomly selected BYU students will be less than 3.3? Round your answer to 3 decimal places. Okay. Plug it in real quick.
Was it a really small number? Like 0.0052?
Yep. So I got 0.0052, but they're only asking for 3, right? So it'd be 0.005.
Okay.
Yeah, that's what I got.
So that you would take the standard deviation of X bar that we just found and the 3.3. So you take 3.3 minus 3.5 divided by the standard deviation of X bar, which was the 0.078. And then you shade in, after you find that z-score, you shade in the left side, and that gives you
Left side.
0.0052 or 0.005. Okay.
Now you just have to do the opposite now.
What's the probability that you is greater? Okay.
Shade to the right.
Okay, so 0.995.
That's what I got.
Okay. Who would like to read the last question?
I can do it.
Okay.
The Coast Guard assumes the mean weight of passengers in commercial boats is 185. The previous value was lower but raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. Weight of random sample of 48 commercial boat passengers were recorded. Sample means was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. I came up with 0.055.
That's what I got.
And I just used all the numbers that were in that were given there. Got the z-score of 1.921, and then plugged it in the formula.
Cool.
And did you first have to find your X bar deviation, standard deviation? So did you take the 48 or the 26.7 divided by the square root of 48?
I went with the 177.6 pounds that they told us the sample mean. I didn't do any calculation on that.
Or no, the standard, did you do a calculation on the standard deviation?
Oh, I'm sorry. No, I just used it as is, divided it by the square root of 47.
The standard deviation is already given to it too. The 26.7.
Okay.
That's
So
what I
is it just did you just take the mean? Or sorry, the mean minus the 185?
That's, yeah. I used the mean that they, of the second study that they did, not the original one.
So you didn't,
The 177.6.
Yes, I
Yeah.
used 177.6 as the mean, subtracted 185, and then used 26.7 as the standard deviation and 48 to square root.
oh, so 26.7 over the root 48?
Yes.
Okay. Oh. That's okay. So I guess that's the same thing that I was saying, but yeah, I did found the standard deviation of the sample mean before I actually put it into the equation. Because when you take a standard deviation divided by the root of the number of samplings, that's the standard deviation of the sample mean.
Right. So you got that?
So it was negative 1.92018.
That's the Z.
What's the z-score?
Right. And then you shade in the left side or the right side and 0.027.
Well, the question is, what is the probability of either extremes, positive or negative?
Okay,
So
add them, so 0.0549.
yeah, so I'm
Yep.
combining both of those.
Okay.
Is that right, Blake?
Yep. That's what I did as well. We got the same answer.
Okay. So you round up to the 0 or 0.055.
That's what I did.
Okay. All right. See if I got that one wrong where I did the 0.148 or whatever it was.
Wait, so what was the answer you got there? I was just working on it.
0.055.
Yeah.
0. What?
0.55.
Okay.
So the 0.148 from that problem from earlier worked just fine.
So they're giving us a few decimal points for variation then.
Yeah. All right, cool. So any other questions before we meet next day?
Yeah, we're going to do the review next time, so it's probably going to be a little more lengthier. So we'll have to write down all the equations and stuff that we can have. So
Okay.
we'll go a little more in depth on that one.
Okay. Sounds good.
Cool.
Great.
Other than that, I don't have any questions.
I'm good. Thanks for your time.
Yep. You guys
All right.
have a great weekend.
Good one.
Thanks.
You
You too.
guys do the same. See you later.